This video is going to focus on sections 8.1.1 to 8.1.2, which is all about sketching graphs of polynomial functions. And then the second section is really just kind of going more in depth. So I'm going to cover both of those sections in this video. So the first thing that you need to know is polynomials can be written in standard form or factored form. So that's just like any other function that we've studied this year. Just like when we have a quadratic function, we can write it as y equals a times the factors x minus b, x minus c, for example. Or we could write it in standard form, ax squared plus bx plus c. So we are going to be graphing polynomials in factored form for this section. And I should modify what I said. We're actually sketching. So graphing and sketching are two different things. So that's important to know when we're doing this. So I have a list of 4 steps on how to graph these. And by the way, I also have a copy of these notes already written out on my website under today's agenda. So the 4 steps I have are, the first thing that you want to do is to find the degree of the polynomial. So for example, you look at the exponents, and if the highest exponent is 5, then that would indicate it's a 5th degree. And then this will make more sense once we look at it deeper, but 5th degree is obviously an odd degree. So odd degrees have a certain shape. Okay. In addition to that, the degree tells you the number of x-intercepts. So if the degree is 3, it's going to have 3 x-intercepts. If the degree is 7, it will have 7 x-intercepts. So that's very important to know. Number 2, identify the orientation. So the orientation just means, is this graph positive or negative? In other words, is it facing upwards or downwards? And we can identify that by looking at the a value and seeing, is it positive or negative? And then number 3 is to identify the x-intercepts. So this should be fairly easy because it is in factored form. So what we can do using the zero product property is set it equal to 0, and then you just set each factor equal to 0 and solve. The last step is to identify any double roots. So double roots are, again, root is just an x-intercept. So that might be something where you have like x minus 2 squared, which means there are 2 x-intercepts technically at 2, and that will create a different shape on the graph. Okay, now this is a little bit overwhelming at first, but once you get the hang of it, it's actually very simple. So the first thing that we are going to do is kind of talk more about that even and odd degree. So we're going to look at some graphs and see if we see any patterns. So these are all just sketches. So for example, if I have x to the first, I know that it is going to look like that. Okay. Now let's say I have x squared. Again, these are all just sketches. If I have x squared, I know it's going to look something like that. Okay. Then I can have x cubed, which would look something like that. And then x to the 4th power, which would look very similar to a parabola, but it just hangs out on the x-axis a little bit longer. So we should be noticing a pattern that odd degrees, it starts and ends in different directions. So if we look at this, it starts down and it ends up. If we look up, it starts down and ends up. X cubed starts down, ends up. Now if we look at any even degree, it starts up, ends up. X to the 4th starts up, ends up. So that's very important to know when we are sketching these polynomials. So what I'm going to do is kind of summarize this information into a smaller amount so it's not so overwhelming. So if we have an odd degree that's positive, you just need to know that it will start down and end up. So let's say it's x to the 7th degree. It will do many things in between, but you know it will start down and it will end up. Now, if I have an odd degree that's negative, we know it will start up and end down. And again, all of them will look different, but they have the same general shape. And then we have even positive. So even positive starts up and ends up, okay? And then lastly, we have an even degree that's negative, which means it starts down and ends down, okay? So again, this will just tell you like where do you even start the graph and where should it end. So we're just focusing on the ends of the graphs, okay? So we're going to go ahead and get started, and we're going to be using those like 4 steps that I gave us to kind of help. So the first thing that we want to do is figure out what degree is this. So if we look at this, we know that this has an exponent of 1, 1, and 1. Okay, so if we were to multiply those together, the highest degree would be x cubed. So this is a third degree, and that means it's odd. Okay, so it's third degree and it's odd. And this makes sense that it's third degree because it has 3 x-intercepts. So it's going to be a third degree. The next thing we want to know is, does this open up or down? And it opens upward, so it's positive. And I shouldn't necessarily say open because it depends on what degree it is, but we just know that it's positive. And because it's odd positive, I'm looking at my little polynomial Bible here. It's odd positive, so it starts down, ends up. So starts down and ends up. That's very important to know. So it's odd positive, so it starts down, ends up. And then we want to find our x-intercepts. So to find the x-intercepts, you set the entire equation equal to 0. So if you set x minus 1 equal to 0, the x-intercept would be 1, 0. If you set x plus 3 equal to 0, you'd get negative 3, 0. And if you set x minus 4 to 0, you'd get 4, 0. Okay, and it looks like we don't have any double roots on this one. So the first step now that we have all that information is let's go ahead and plot our x-intercepts. So we know we have an x-intercept at 1, 0. We have an x-intercept at negative 3, 0. And we also have one at 4, 0. Okay. Now I'm going to think back to that whole, is it even, odd? So we know it's an odd degree and we know it's positive. So I know that it's going to start down and end up. The other thing we know about x-intercepts, it's where the graph crosses through on the x-axis. So it has to cross through all those x-intercepts. So I am not at all concerned with my y values, okay? So we're not worried about how high or how low this is going in any way. So we're going to start down. We go through the x-intercept, and then I know I'm going to have to go through the other one, so I'm going to eventually go back down. And then I know I have to go through the other one, so I go back up. Let's see if this makes sense. So is this an odd positive? Well, yes, we start down and we end up. The other thing is it's a third degree, so it crosses the x-axis 3 times. The other thing that we didn't talk about is the turning points. So the turning points are here and here where it changes directions. So it's always going to have one less turning point than the degree. So since it's a third degree, we're going to have 2 turning points. All right, let's go ahead and try the next one. Okay, so first thing is figure out what degree this is. So we have 4 x's here, and if we were to multiply all of them together, we would get x to the 4th. So this is a 4th degree, which means that it's even, because 4 is even. Okay, and that makes sense that it's a 4th degree, because if you look, it has 4 x-intercepts. So the degree tells you the amount of x-intercepts. All right, the next thing is it positive or negative? Well, this one is negative because it has a negative sign in front. Okay, the last one, if we look at, didn't have any sign, so it's positive. So because it's even negative, I'm going to look back up here. Even negative starts down and ends down. So I'm going to go ahead and put that. So starts down, ends down. So that's important to know so we can sketch our graph. Okay, and then the next step, we have to find our x-intercepts. So if I were to set each of those equal to 0, we would have -2, 0, -1, 0, 3, 0, and -4, 0. All right, so let's go ahead and plot those x-intercepts. So I have -2. I actually want to do this in purple. Okay, so we have -2, and then -1, 3, and we also have -4. Okay, so we know because this is a fourth degree, it has 4 x-intercepts, so it has to cross through all of them. We also know that it's negative, and following the even negative pattern, it starts down and ends down. So I'm going to start down here, and then I have to go through each x-intercept. Remember, we're not worried at all about the y values, so I'm just kind of estimating. And then we have to go through that one. All right, so it's going to look something like that. And this makes sense. It's fourth degree, and it has 3 turning points. All right, let's look at our last one here. So the degree of this, well, the first x would have an exponent of 1, and then the next one has 2, so this would be a third degree, which makes it odd. Okay, the other thing is it a positive or negative orientation? This is negative because it has a negative sign in front. So because it's negative and odd, I look back to my little polynomial Bible, I call it. So it starts up and ends down because it's negative odd. So starts up and ends down. Okay, next thing is to find the x-intercepts. So if I were to set -x equal to 0, I would just get 0. So we're going to have an x-intercept at 0, 0. And then I would also have an x-intercept at 2, 0. But this is what we call a double root. Okay. So next is we graph this. So we're going to go ahead and graph our x-intercepts. We have 1 at 0 and 1 at 2. Now, we know that it's odd negative, so we know that it's going to start up and end down. Okay, so it starts up and ends down. The other thing is at 2, it's going to have a bounce. So I'm going to start up here. I go through 0. I know it has to go to 2. Instead of crossing through, it has to bounce off of it and go back down. And again, that happens when you have a double root or something like x minus 3 squared. So let's see if this makes sense. Well, we still technically have 3 x-intercepts for a degree of 3, and we still have 2 turning points when we have a degree of 3. Okay, so this is how you sketch polynomials in factored form.